In the previous video, we have shown that for a general three-port network, the three conditions, lossless, reciprocal, and matched, cannot be satisfied simultaneously. However, we can satisfy two of these conditions while the other condition or the third condition is not satisfied. Now in this video, we are going to show two examples for three-port networks which satisfy two of these three conditions. The first network is non-reciprocal, lossless, matched three-port network. This means that we have ignored the reciprocity property. So it is lossless and matched, but it is not reciprocal. So if the three-port network is non-reciprocal, this means that Sij doesn't equal Sgi. If I'm going from port 1 to port 2, it's not the same as if I'm going from port 2 to port 1. This means non-reciprocal network. And the conditions for the input matching at all ports and energy conversion should be satisfied. So in this case, Sii or S11, S22, S33 are 0. So input matching is satisfied for all ports, and at the same time the energy conversion, it means that if I take the magnitude squared of any column or any row or any row, so they should be unity. This is the energy conversion. So if the three-port network is non-reciprocal, then Sig doesn't equal Sgi, and the conditions for the input matching at all ports and energy conversion can be satisfied. Actually, this network is called circulators, and we are going to study these circulators in more details in chapter 9. But now we are going to study only the scattering parameters of such circulators. So such a device is known as a circulator and generally relies on anisotropic material. Actually, the anisotropic material in the circulator are ferrite material, such as ferrite, to achieve such non-reciprocal behavior. The general S parameters for this non-reciprocal lossless matched three-port network is as shown. S11 is 0, and we have S12, S13. S21 does not equal S12, S22 is 0, S23, and S31 does not equal S31, S32 does not equal S23, and S33 equals 0. Now, by taking the magnitude of the magnitude square of any column or any row, we say that the magnitude of S12 squared plus S13 squared should equal unity. This actually means that the bar going from port 1 to port 2 and plus the power going from port 1 to port 3, it should equal the total bar going from port 1. And in a similar way, S21 squared plus S2C3 squared equals 1. Finally, the magnitude of S31 squared plus the magnitude of S32 squared equals 1. In addition to this condition, the other condition is the conjugate of any column multiplied by the other column should be equal 0, or the conjugate of any row multiplied by another row should be 0. This means that if we are taking the conjugate of the first row multiplied by the second row, the first term is 0, the second term is 0, the third term is sorry, I'm talking about the conjugate of the first column multiplied by the second column. So the first term is 0, the second term is 0, and the third term is S31 conjugate multiplied by S32. This must equal 0. And the conjugate of the second column multiplied by the third column the conjugate of the first column multiplied by the third column. 0 multiplied by S13 is 0. S21 conjugate multiplied by S23. The third term is S31 multiplied by 0. So we have only S21 conjugate multiplied by S23. This should equal 0. Finally, the conjugate of the second column multiplied by the third column. S12 conjugate multiplied by S13, and the other two terms are 0, should be 0. So, to be lossless, these two conditions must be satisfied simultaneously. And previously we said that S12 does not equal S21 because it is non-reciprocal, and S13 does not equal S31. Alright? Okay. So these are the two conditions. To satisfy these two conditions simultaneously, we can say that we can choose S12 and S23 and S31 to be 0. S12, S23, S31 to be 0. So the three equations are satisfied in this case. Now, if S12 is 0, this means that S13 should be 1. And if S23 is 0, this means that S21 should be 1. And finally, if S31 is 0, this means that S32 should be 1. So, if S12 equals S23 equals S31 are 0, then the magnitude of S21 equals the magnitude of S32 equals the magnitude of S13 equals unity. So these S parameters, these 6 S parameters, satisfy these two conditions simultaneously. So this is one solution for such non-reciprocal lossless matched network. Another solution, instead of saying S12, S23, S31, we can say that S13, S21, S32. S13, S21, S32 are 0. Then, from the second equations, or from the second set of equations, we can say that if S21 is 0, then S23 is 1. The magnitude of S23 is 1. If S32 is 0, then the magnitude of S31 is 1. Finally, if S13 is 0, then the magnitude of S12 is 1. So, these 6 S parameters also satisfy this condition. So, now we have two solutions which satisfy the condition for the lossless case. And both two conditions are non-reciprocal, because here S12 does not equal S21, S23 does not equal S32, and S31 does not equal S13. So this result shows that Sij does not equal Sgi, for I does not equal j, which implies that this device must be non-reciprocal. Right? For the first solution, let us write the resulting S parameters as a magnitude. Here, S11 is 0, S12 is 0, and S13 is 1. Now, S21 is 1, S22 is 0, S23 is 0. Finally, S31 is 0, S13, sorry, S32 is 1, S32 is 1, and finally S33 is 0. If we look at this report network, we can say that if the excitation coming from port 1, the output will be obtained at port 2. So the power going from port 1 goes to port 2. Now, if the excitation or the input power is from port 2, the output will be at port 3. So if the power is going inside port 2, the output will be going from port 3. Finally, if the input is going from port 3, the output will be from port 1. If the input power is going from port 3, the output power will be from port 1. Actually, uh, this configuration has a very important application in radar application, for example, where we use the antenna as a transmitter and a receiver at the same time. So the power amplifier or the output of the power amplifier is connected to port 1 and the antenna is connected to port 2. So the power going from port 1 go to the antenna. The power from port 1 goes to the antenna. The antenna radiates the power, then the scattered signal or the received signal going to the antenna to port 2. The received signal in this case goes from port 2 to port 3 to the low noise amplifier which is connected to port 3. So we connect the output of the power amplifier to port 1 and the input of the low noise amplifier of the receiver to the port 3, and at port 2 we are going to connect the antenna which works as a transmitter and receiver at the same time. Okay. The other configuration for the circulator, when S21 equals S32 equals S13 equals 0, while the magnitude of S12, S23, S31 equals 1. In this case, S11 is 0, S12 is 1, S13 is 0, S21 is 0, S22 is 0, S23 is 1, S31 is 1, S32 is 0, and S33 is 0. So if the excitation is going from port 1, the output in this case will be from port 3. So if the excitation or the input power is going inside port 1, the output will be from port 3. If the excitation from port 2, which is the second column, the output will be from port 1. So if the excitation is going from port 2, the excitation is coming from port 2, it would be go outside from port 1. Finally, if the excitation is coming from port 3, the excitation is coming from port 3, the output will be from port 2. This is briefly the basic operation of the circulator. We are going to study this circulator in details in chapter 9. But at least now we have an example for non-reciprocal matched and lossless network or three-port network. All right. Another configuration is lossless and reciprocal, but not completely matched. Lossless reciprocal three-port network. So in this case, we have the condition of lossless network. We have the condition of reciprocal network. The condition for reciprocal network is that Sij equals Sgi. So S12 equals S21, S13 equals S31, and S23 equals S31. In this case, we are going to assume that the network is not completely matched. So, assuming that it is matched at port 1 and port 2, but it is not matched at port 3. So, port 1, S11 is 0, port 2, S22 is 0, but S33 is not 0. So, if ports 1 and 2 are matched, but port 3 is not matched, so this is the S parameter in this case. So, because it is reciprocal, it is symmetric. Because it is not matched, it is not completely matched, we are assuming that only S33 is not matched. Alright? In this case, to satisfy the condition for lossless, this means that if we are going to sum the magnitude square of any row or any column, it should be unity. In addition, the multiplication of the conjugate of any column by another column or any row by another row, it should be 0. These two conditions should be satisfied such that the network is lossless. So, according to this condition, S12 squared plus S13 squared should equal unity. S12 squared plus S23 squared should be unity. S13 squared plus S23 squared plus S33 squared should be unity. The other condition is if we are talking about the first what? The first column, the first row conjugate multiplied by the second row, we can see that S13 conjugate multiplied by S23, and the remaining two terms are 0, so this would be 0. If we multiply the conjugate of the first row with the third row, it would be the first term is 0, S12 conjugate multiplied by S23, S12 conjugate. Yeah, here, okay, this is the third one. S32 conjugate multiplied by S12 plus S3 conjugate multiplied by S31. This is the third one. If we are going to multiply the second and the third, it would be S12 conjugate multiplied by S13 plus 0 plus S23 conjugate multiplied by S33. So we have these three equations combined with these three equations. This equation should be satisfied to say that this network is a lossless network. Alright? So according to these two equations, we can say that S12 squared plus S13 squared equals 1, and S12 squared plus S23 squared equals 1. This means that S13 squared should equal S23 squared. Sorry, S13 equal S23, right? Alright. Now, if we have this equality, and we say that S13 conjugate multiplied by S23 equals 0, and they are already equal in magnitude, this means that S13 equals 0 and S23 equals 0. So, from these two equations, we proved that S13 equals S23. And from this equation, we proved that if they are equal and their multiplication is 0, so both of them are 0. S13 equals S23 equals 0. Alright? Now, if S13 equals 0 and S23 equals 0, returning back to this equation, 0 plus 0 plus S311, this means S311 should equal unity. And if we say that S13 equal S23 equal 0, S13 equal to S23, S13 equal S23, this equals 0, right? And S13 equals 0, okay. So both of them are 0. All right. Now S1, 3, S2, 3 are 0. So S1, 2 should equal 1. S1, 2, because S1, 3 is 0. So S1, 2 should equal 1. So from these conditions, we have obtained S1, 3 equals S2, 3 equals 0. And the magnitude of S1, 2 equals the magnitude of S3, 3 equals 1. So these are the conditions which are satisfying the conditions that would be lossless, reciprocal, and not matched network. Let us see how this can be implemented. We say that S13 equals S32 equals 0. S13 equals S23 equals 0. So this 0, this 0, this 0, and this is 0. And S12, S21 equal unity. S33 equals unity. So this one and this one. Actually, this means that all the power going from port 1 will go to port 2. And all the power going from port 2 will go to port 1. This means that the connection between port 1 and port 2 is simply a transmission line section. On the other hand, all the power going from port 3 would be reflected. This means that the port 3 is simply connected to a short circuit, for example, or open circuit. So the equivalent circuit in the case of lossless reciprocal 3-port network and it is matched at port 1 and port 2 and not matched at port 3 is simply a transmission line going from port 1 to port 2 and short circuited port at port 3. This means that there is no power completely going from port 1 to port 3 or from port 2 to port 3, or in other words, port 3 is completely isolated from port 1 and port 2. Actually, this condition is not a condition for a power divider or directional coupler. So the general lossless reciprocal network, which is matched at port 1 and port 2 and only not matched at port 3, does not is not suitable for any power divider or any directional coupler. This briefly two types of networks. One is non-reciprocal network, which was the circulator, and the other is reciprocal and lossless, which is simply transmission line going from port 1 to port 2 and isolated completely from port 3. The first network is useful in microwave circuits, which is a circulator, but the second network is actually does not represent a useful network for direction coupler or bar divider. All right. Okay.